Okay, let's give you guys some practice now. So find the quadratic approximation of this near x equals 0. So to do this here, you would have to start out with your guess your guess quadratic. So I don't know, hang on, maybe something like this. Okay, so start out with your guess quadratic, which will be in this form here. Okay, and then the trick is to make sure that the derivative, the first derivative of this will be the same as the first derivative of the red line, and then the second part of the trick is to make sure the second derivative of the black line will be the same as the second derivative of the red line near x equals 0, near this region here. So that's our trick. Okay, so start out with this. Make sure that this will be the same as this. So at x equals 0, so you put 0 into here, then this will be 0, this bit here will be 0, just leaving you c. So c, and then you put 0 into your original function here. So the natural log, or remember this is 0, 0 plus 1 is 1, so the natural log of 1 will be 0. So the point is that when you put 0 into here and into here, then 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 this thing here, then c will be 0. So already you've got c here. C here is 0. Your job here is to find out a and b now. And the trick to doing that is to make sure that the first derivative of our estimate here, the first derivative of the black line here will be the same as the first derivative of the red line, and so on. And then later on, do the same with the second derivative. Okay, so far C has been done. Now you've got to find out A and B, and the way you do that is to look at the first derivative and the second derivative. Make sure the first, well, just press pause and have a go. Okay, so find A, B. Well, I've already done C for you, so find out A and B. So press pause and have a go. Okay, so to do this here, now, so we would start out with our quadratic here, our guess here, and we know that C here so far is 0 because of this bit here. Okay, because of this bit here, and now we've got to find out A and B, and the way we do that is to look at our original guess, sorry, our guess quadratic here. Around this region, we want to make sure that our guess here, the derivative of our guess will be the same as the derivative of the original one here. Okay, so the trick here is to start out with this, and then differentiate it. So now differentiate this. So now differentiate this. That will then give you this, and then differentiate this. That will then give you this. And make sure that this we want the gradient. We want the gradient of our quadratic approximation to be the same as the gradient over here. Okay, and then put 0 into here, because we are evaluating it at x equals 0. We are evaluating it around this region here at x equals 0. So put 0 into here. Put 0 into here, and then this will be 0. That means that this whole thing here will be 0, leaving you just b. So when you put 0 into here, the whole thing here will just be b. Now put 0 into here, and then this whole thing here will be 1. So you want to get it such that the gradient of our quadratic approximation will be the same as the gradient of this of our original function here. So now b is b equals 1. Okay, because we want to set it. So we want to find out a, b, and c. You see, if you set b to be 1, then our quadratic will be the first derivative of our quadratic will be the same as the first derivative of this. Well, anyway, set b to be the same as this. And then now the second part of the trick is to differentiate it again. Look at the second derivative. So from here, now let's look at the second derivative. So this here is our first derivative. Now differentiate this, so that will take us to this. Okay, so the second derivative of our quadratic will be given by this. Now we want to find we want to compare that with the second derivative of this as well. So looking at this here, rewrite this as, because we want to differentiate this. Okay, so meaning you have to differentiate this. Well, to differentiate this, I'll rewrite it as this. Okay, so this thing here is exactly the same as this. But then when you've written it in this form here, you can easily differentiate it. So this goes down, giving you the -1, and then this here gets minus by 1. Okay, and then blah blah blah, tidy up. That will give you this. So the second derivative is this. The second derivative of our quadratic is given by this. We want to set this to be the same as this. Okay, so let's evaluate it at x equals 0. So now, hang on. So this is our second derivative. This is our second derivative here. Put 0 into here, and then this will remain at 2a because there's no x around. So even when you put 0 into here, it remains 2a. Now put 0 into here, and this whole thing here will be -1. So now you want to find out the value of a where this will be the same as this. So a is really -1/2. Okay, so therefore a equals -1/2, b equals 1 from earlier, c equals 0 from earlier. So now we can start out with our original quadratic here. So we've now remember, we want to create a quadratic so it will be a good fit. You see, if you set this a to be this, set this b here to be this, and set c to be 0, then you would get this. So this is our quadratic approximation. So get yourself a graph plotter, plot the original function, and then plot in our quadratic approximation. That will then give us this. You see, around x equals 0, it is pretty good. It is pretty good around here. Okay? So this here is our solution here.